Welcome. In this video we'll be solving trigonometric equations involving sine part 2. Let's take a look at our first example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Notice that the equation is sine of theta plus pi over 6 is equal to square root of 2 over 2. So what we're going to do is to introduce a new variable, namely alpha. So let alpha be equal to theta plus pi over 6. Now we're introducing this new variable so we can rewrite the original equation in a simpler way. So this now becomes sine of alpha is equal to square root of 2 over 2. Now keep in mind that y is equal to r sine of theta. Since we're dealing with the unit circle, we know that the radius is equal to 1, so we have y is equal to 1 times sine of theta, or equivalently, we have that y is equal to sine of theta. So going back to this equivalent equation, we can say that we're looking for angles such that the y-coordinate is equal to root 2 over 2. So looking at your unit circle, we come across any points that have a y-coordinate of square root of 2 over 2. So here's one of them. And then when you come across here or around, you get that this is the other point. So we get that the corresponding angles are pi over 4 and 3 pi over 4. So we get that alpha is equal to pi over 4 or 3 pi over 4. Now that's really nice. However, that's not the solution to the original equation because the original equation involved theta, not alpha. So what we're going to do is to take each of those values and go back to replace these values and for alpha. So we have the following. For alpha is equal to pi over 4, let's solve for theta. In other words, since you have alpha is equal to pi over 4, instead of alpha, we're going to go back and use the substitution that we did. So we know that alpha is theta plus pi over 6. So let's go ahead and substitute that in. And we know that this is equal to the right-hand side, which happens to be pi over 4. Now, our goal is to get the theta by itself. So let's go ahead and subtract pi over 6 from both sides of the equation. And this leaves you with theta is equal to pi over 4 minus pi over 6. Now, looking for a common denominator, we know that the common denominator for this two is 12. So we're going to multiply this one by 3 over 3. Thus getting 3 pi over 3 times 4. Minus, we're going to get this to become a 12, so we need to multiply this by 2 over 2. So we have 2 times pi over 2 times 6. Now, this now becomes 3 pi minus 2 pi, which is pi. And then 3 times 4 or 2 times 6 is 12. So we get that one of the angles for theta happens to be pi over 12. Now, we're going to do the same process, but now for alpha equal to 3 pi over 4. So let's solve for theta using that particular value. Therefore, we have alpha is equal to 3 pi over 4, but alpha is nothing else than just theta plus pi over 6. And that is equal to the right-hand side, which we said was 3 pi over 4. Now, our goal is to get the theta by itself. So we're going to subtract pi over 6 from both sides of the equation. Now, this gives you that theta is equal to 3 pi over 4 minus pi over 6. Now, looking for the common denominator, we're going to multiply this by 3 over 3, so we can make a denominator of 12, and this one by 2 over 2, so we can make the denominator a 12 as well. So this now becomes 3 pi over 4 times 3 over 3 minus pi over 6 times 2 over 2. So we get that theta is equal to 9 pi over 12 minus 2 pi over 12. Now subtracting, since we have the same denominator, Okay, that's a 12. We have 9 pi minus 2 pi becomes 7 pi over a common denominator of 12. So that's our second value for theta. Therefore, your solutions for this equation will be the first one, which we said was pi over 12, and the second one, which we said was 7 pi over 12. Let's see another example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. So once again, we're going to introduce a new variable called alpha. So let alpha be equal to theta plus 3 pi over 4. Now, that will enable us to rewrite this original equation as follows. This now becomes sine of alpha is equal to 1/2. Now, remember one more time that y is equal to r sine of theta. And on the unit circle, you have that y is equal to 1 times sine of theta, or equivalently, y is equal to sine of theta. So we're looking for any angles whose y-coordinate is equal to 1/2. So what are those angles? Well, let's look at our unit circle. If we're looking for y-coordinates of 1/2, we notice that this point has that, and if we reflect across the y-axis, we get that this is another point that has that particular coordinate. Now, we can say that alpha can be either pi over 6 or 5 pi over 6. Now, with that in mind, we're going to use the previous substitution to solve for theta. So let's say the following. For alpha is equal to pi over 6, let's solve for theta. And we know that alpha is simply theta plus 3 pi over 4 is equal to your right hand side, which is pi over 6. Now we're going to subtract the 3 pi over 4 from both sides to isolate the theta. And we simply get that theta is equal to pi over 6 minus 3 pi over 4. Now looking for a common denominator, which happens to be 12, we're going to multiply this one by 2, so we have 2 pi over 2 times 6, minus, let's multiply this one by 3, so we have 3 times 3 pi over 3 times 4. So 3 over 3 as a convenient way to multiply and get the same denominator. Now this becomes theta is equal to 2 pi over 12 minus 9 pi over 12. We do the subtraction and we get that theta is equal to negative 7 pi over 12. However, this theta is not between 0 and 2 pi. So we're going to make use of the fact that this function, okay, our original function sine of theta plus 3 pi over 4 has a period of 2 pi. So what we're going to do, we're going to say, okay, our actual angle theta, okay, is equal to negative 7 pi over 12 plus the period of 2 pi. Now again, we need to get the same denominator, so let me multiply this one by 12 over 12. So this gives you negative 7 pi over 12 plus 24 pi over 12. Now doing the math, we get that 24 minus 7 becomes 17. So this is just 17 pi over 12. And that's one of your angles here. Now let's use the other one. So for alpha equal to 5 pi over 6, let's solve for theta. So we get the following. We get that theta plus 3 pi over 4 is equal to 5 pi over 6, since alpha is the same as theta plus 3 pi over 4. Now, in order to solve for theta, let's go ahead and subtract 3 pi over 4 from both sides. Thus, we get that theta is equal to 5 pi over 6 minus 3 pi over 4. Now, looking for the same denominator, which happens to be 12, let's go ahead and do some multiplications here. So I'm going to multiply this first part by 2 over 2. So we have 2 times 5 pi over 2 times 6 minus the second part will be multiplied by 3 over 3. So 3 times 3 pi over 3 times 4. So we get that theta is equal to 2 times 5 is 10 pi divided by 12 minus 3 times 3 pi becomes 9 pi over 12. Now, doing the subtraction, we get that this is equal to just pi over 12. And that happens to be your second solution for this equation. So we can say that in conclusion, our solutions happen to be pi over 12 and 17 pi over 12. So we'll stop here for this particular video. Thank you for watching and have a wonderful day.